So to this point, we've been studying what I was calling baby objects, or pretty standard objects, where we have some instance variables, and then we have accessors and mutators, and we have a toString and a compare to and all that stuff. I want to do a more complex object today, and the one I want to discuss is called a stack. And a stack is also something called an abstract data type. And abstract data types are standard objects that are used for storing data. So users are very unaware of these. These are very, as I say, abstract, and they come behind the scenes. You'd study them probably in second year university, maybe first year university, depending on where you go. The reason why they're in the grade 12 curriculum, much like objects, is that these are very big concepts, and they want you to be exposed to them a series of times so that university goes a bit more smoothly when you get there. All right, so ADTs are all very well designed and coded. They've been very specifically structured to be super fast. They're going to do one very specific task. You'll see that the stack is really narrowed to one thing, and it does it really, really well, but it doesn't do anything else. So the examples that we're going to look at are the stack, the queue, and the tree. But something that you might look at university is you might look at a heap or a hash table. And there's some others, but those are some pretty standard ones. So a stack is an ADT, and it follows what's called a LIFO structure, which means that the last thing I put on the top of my stack is the first thing I'm going to pull off. And if I pull something out of the middle of my stack, it all falls over. So I'm always working on the top of my stack. When you're coding, this is actually what's used for the back button in your browser, or the undo button on, like, I don't know, Microsoft Word. It's also used in recursive calls. So you recall that we called it a stack overflow, because every time we call something when we're doing recursion, we add the call to the stack. And if we have it so that it's infinite, then our stack will overfill. So the stack functions, the two big ones, are called push and pop. So push adds to the stack and pop removes from the stack. With a stack, you can't do anything else. Like, you can't be grabbing something out of the middle. That's not how it works. The pile will fall over. So let's trace some code. So the first line is the constructor call. You can see that because it has new in it. So it says new stack. So what I do when I'm drawing that is I normally draw a line, and then I put the name of the stack, in this case S. I often call my stacks S, there so that I can remember which one it is, in case I have like 5 stacks. So then the next line says S dot is empty. Well, is S empty? Well, yes it is. So that's going to return true and print it on the screen. So the next line says that we're going to push 9 onto the stack. So there we go, we've pushed 9 onto the stack. Then we're going to push 8 onto the stack. So then we always add to the top, so then there you see 8 is added on top of 9. Then on line 5 it says that we need to find S dot size. Well, it's 2 because there's 2 things in it. So then we're going to push a 7, so the 7 goes on top of the 8. And then the code asks us to pop. So the thing that gets popped is the thing that's on the top. So that is 7. And one of the things to notice here is that push always has a parameter because we're always having to add a specific thing. But when we pop, we don't need a parameter because whatever's on the top is the thing that gets popped off. You can call s.pop just by itself, or you could print it out, or you can save it, whatever you'd like to do. It has a return type, but you don't have to catch the return if you don't care. All right, so the next thing that happens is it tells us to push 6. So then we'd add 6 to the top of the stack. Then we pop, so then 6 comes right back off. Then we have s.size. Well, it's 2. I can see that I've got 8 and 9 there. And is it full? Well, no, because we actually added more things, so no, it's not full. And is it empty? Well, it doesn't look like it. There's 2 things in it. So those are some basics of how you would declare your stack, and then you would call on the stack, on your object, you would call these various functions. Is empty, is full, and size are accessors because they allow us to tell things about the stack. Push and pop are mutators because they're going to change the stack around. Stack is the constructor. So let's take a look at a browser button. So let's say you're on YouTube. So you'd have some kind of stack stored in there. I'm going to call mine back. And it would store the fact that you're on YouTube. So then you might go to another really awesome website, your favorite website in the whole internet. And then you maybe will go to Google, and maybe you'll go to Twitch, and then you'll hit the back button. So when you hit the back button, Twitch gets popped off, and then your browser knows that it needs to go to Google. So then maybe you could go forward from that point and go back to your favorite website in the world. And you can see that the stack of where you have been is how the back button is going to be working on a browser. So I just want to remind you that an object we had defined as data and the methods that act on data. So a stack is an array to hold the stack stuff and a counter variable that tracks the top of the stack. And it's also these functions. So peek allows you to see the top, pop allows you to pull something off, push allows you to put something on, size is, what's the size, is full, is empty, or, well, is it full, is it empty, and a toString function, which actually isn't in the classic stack, but I put it in just to make our coding better. And the stack is really good for encapsulation. We're going to group together the stack's data, its array that's tracking all this stuff, and its methods. That's going to make it really self-contained, and so that any programmer who needs to code a back button or an undo button can use it very easily. I also wanted to remind you that with objects, our user has changed. It's no longer, a regular person, but now our user isn't this clueless individual. It's going to be a fellow programmer. So stacks are a really great example of information hiding. I actually haven't pointed out to you about how push or pop are coded at all yet. We have no idea, but you can still call them and understand them and use it to make a back button with no understanding of the details inside it. So you can be like the patting the furry puffball about a stack, and you can use it just fine. So we're going to be making this part private because we don't want our users to be messing up with it, our fellow programmers, and we'll make all the methods public. So the code to make a stack looks like this. I made one specifically for strings, so I called it stack string. And I don't want to go over the code in exhaustive detail right now because I don't really care that you understand it at this point. But I just want to point out that here we've got our private variables and things like that occurring. But I want to show you something else. Do you see how there's no loop in the constructor? No loop in push, no loop in pop, no loop in peek, no loop, no loop, no loop, no. There's no loops. All of these functions are constant time. That's insane. Stack is super fast. So when you're running your stack, I've got an example here with Eclipse, but just to show you a different example, you're going to make your stack string.java class, and you're also going to have another program that's going to run it. So in my other program that runs it, I've got a stack where I've created it, and then I've pushed and popped and done various things there so I can see what's going on. And so again, we have the two files that we're working, the stack and then the other code that runs it. Here is some more detail about the stack runner, and so on. Okay, there's also a tracing video that you may find helpful. So the summary information is that it's an ADT, it's an object, it's a LIFO structure, it's got these functions, all of its operations are order 1, but you are limited to stack functions, and its speed is from the fact that you're restricting the functionality. You would never sort a stack, because the order of the stack is the order that you want. If for some reason you didn't want that order, then you actually don't want a stack at all. You want an array. So here's your card for stacks, and you might want to take a look at the other video.